Okay. Anyway, that is what it is. I didn't say that officially. But anyway. Okay, so keep that in mind too as we're going along. But I can't have that up. I'm not allowed to. I don't know if the board can get sued or I can get sued, but it's a copyright infringement, right? So that's not cool. All right, so the earliest one is 3B. So we have X, oops, sorry. And I realize that some of this stuff is happening pretty quickly for you, okay? Oh, wait, that's A. I realize that some of this stuff is happening quite quickly for you. So I do understand if you have some sort of, pause or trepidation or whatever with all of this, and you're still sort of ironing it all out. We've gone a little bit slower in this unit than we have or will in the other units in some sections, and been a little bit more gentle with you. You may be like, oh my God, really? But yeah, so keep that in mind, okay? Because we're still, getting back into our math mindset and things like that, okay? So don't feel weirded out if you're not 100% about this stuff up to this point, okay? We still have the weekend. We still have Monday before we have the test. And you may even have Tuesday, okay? You may even have Tuesday. Okay, I'm banging that around. I actually got to talk with Miss Lamanna, who's also teaching the grade 11 this quad master, and we're going to talk about how we're going to do our testing and stuff like that. So we'll see. Okay. All right. So here we go. Okay. First step is what?
X squared minus 9 is a perfect square, so it's x minus 2 plus x plus 2.
Excellent description of what operation? Factoring. First step, factor. Second step? Restrictions. Third step? You do the operation, right? If it's addition, you do addition, subtraction. If it's multiplication, you multiply. If it's divide, you divide. Okay? But that's very good. Very good description of what we're doing. Absolutely. It's like saying, who is that? Well, that's a guy who's in his late 40s, wearing a blue shirt and beige pants and devastatingly handsome, etc. And you're describing me, of course. That'd be like saying, oh, just Mr. Henley, right? But that was a joke. I didn't embarrass you, did I? She's okay. Olivia's tough. She can take it. All right, and yeah, this is a difference of squares. Excellent. We want to try and recognize that. You could use a decomposition method with this, or say what multiplies to give me -9 and adds to give me nothing in between or 0. You could factor it, but ideally, hopefully you're recognizing that difference of squares. Okay? Now, this is kind of the tough part. Well, not the restrictions. Okay, so wherever you want to state the restrictions, as long as you write it down, I really don't care. If you want to do it as a line, that's fine. You want to do it off to the side, that's fine. Just don't do it on a scrap piece of paper and not tell me. Okay? All right? In this case, a lot of people are very comfy with just saying my restrictions x cannot equal -3. They just look and say -3 plus 3, that's 0, right? Okay, and the same thing here for this one and say, oh yeah, also x cannot equal 3. But remember, when we have the ones where we have a coefficient in front of the x or the t or whatever it is that we're doing, it is a good idea to set it equal to 0 or not equal to 0 and then isolate. Okay? I really do recommend that for those ones, but it's up to you. I mean, it depends how good you are with solving equations in your head. This is the sort of big step. This is the step that is the most difficult, and that's the LCD, right? Okay, so first you look for a monomial component. Here's our monomial component of any of these denominators. No, that's a two-termer, and the two-term, right? So no. Okay, then we look for the binomial component. The binomial component of the lowest common denominator is actually pretty easy. What you do is you say, okay, what varieties of binomials do I see? Well, I see an x plus 3. So I know my denominator is going to have to at least include that, right? And then I look further and I'm like, well, that one's got an x plus 3 too, which is cool because it's already common, but this one also has an x minus 3. That would be analogous to you having a 1 over 3 and then having a 1 over 6. Do you understand what I mean? Because 1 over 6 can factor to 3 times 2. You see? So they do have something in common. 3 goes into that guy and 3 goes into that guy. But then we know what the common denominator is between these two. It's 6, right? I have to multiply it by what's not there in order to make it the same. And that's my next step once I have my lowest common denominator. Okay, so I built my lowest common denominator, and I say to myself, well, this is going to look like this. To make it look like that, it doesn't regularly have that. So it's always good to bracket this expression and then multiply top and bottom by whatever's missing from the denominator. Are we okay with that? Good? Because this is kind of tough. Okay. But for some people, maybe it's easy. I don't know. Whatever. No offense. I don't care if you find it easy. If you do, I'm very happy that you find it easy. But some people that are finding it difficult, I want to know about. Okay? Because we've already figured. You already figured it out. If you already figured it out, you're cool. Okay? Cool meaning good, not cool meaning cool. 2 times x, 2 times negative. Oh, sorry. Yeah. Write it all over the same denominator. Okay? This, believe it or not, is a step that a lot of people either A, don't do, or B, don't really care about. But the key feature here is I've really simplified because I've gone from 2 fractions to 1. Now you may think of yourself, well, I don't even know why that's better. I have to trust Mr. Henley. But next year when you're graphing these guys and understanding how they behave, to go from 2 functions or 2 fractions down to 1 function is huge. Do you guys understand? Okay, so, or you believe me? You don't really have to understand because I'm just telling you. Okay, and then we have our 2, I guess I could do this line, x plus, oops, sorry, x minus 3. Oops. X minus 3 and then plus 7. Okay. I didn't have to do anything to this denominator. I guess you can multiply top and bottom by 1 if you wanted to. Okay. Then you expand it out. I get 2x minus 6 plus 7 over x plus 3, x minus 3. And then it's just simply 2x plus 1. Okay, not too crazy. Okay, finals terms, I'm not always going to do this just because of time constraints. We restate and restrict. Okay, so therefore, our original question, okay, is equal to this. Okay, and then don't forget, of course, that x cannot equal 3 and negative 3. And remember, I don't state restrictions at the end. Okay, I need the restrictions at the beginning. Because some of those restrictions are holes if they cancel out. And if they don't cancel out, then they're asymptotes. And you don't know what those are yet. But we will know after our next unit what an asymptote is. Okay? Good? Okay, so that's that one, 3b. Okay, it's a good one because just a binomial common factor. I forget what the next one's, 5 something, wasn't it? 5b. Okay. And you will be doing more tough or more difficult versions of these. So here's some monomial common factors, so that's good. This is a good one to do, by the way. 3 over t to the 4, oops. 3 over t to the 4. 1 over t squared, 2t squared. And then minus 3 over 5t. Okay. So, in this case, we have monomial common factors. Okay? But, we still have to go through our first 2 steps. First step? Factor. Well, that's factor. That was easy. Second step? Sorry?
Restrictions.
That's the masks. I can't hear you with the masks. Restrictions. Either that or you're just not having fun. In this case, whenever I have a monomial, what is it really? What can x not equal? 0. It's like a robotic sort of thing. Right? Because you just plug in 0 for that and the whole thing's 0. Even if you plug in a 0, you're going to multiply it by 2. Or square it and then multiply it by 2. It's still going to be a 0. It's still going to be a 0. So is any monomial, just look at the variables that are in the monomial and set them not equal to 0. Okay, hopefully you've gotten that sort of pattern by now, or that idea by now. We're going to need more. Not for this one, probably. Okay? So we did our factor step, which was nothing. We got our restrictions. Now we want to do our LCD. What's our LCD going to be? Well, again, we build Do you know the whole thing?
Yeah.
How about you give me the number part?
Well, you got, 10.
10. Where'd you get the 10 from?
Well, 5 times 2 is 10, 2 times 5 is
Okay, but ideally you don't want to just multiply them all together, because if I had maybe a 4 here, well, no, let's put the 4 out. I'll put the 4 out here. Then it's a 4t to the 4.
That would be a different one.
Right? You wouldn't want to go 4 times 2 times 5. That would be 40. Sorry?
I didn't do that, just know it's 10.
No, no, I know. But you want to be careful you don't just multiply them all together, because you want the lowest. Okay, but you know, no, that's you could reduce afterwards. That's fine. It's just sometimes with algebra, with rational expressions, it gets pretty crazy. The powers and stuff like that that are in there. Okay, what about the power? Olivia wants to, I know, but she can't answer all the questions. Wait, Martin? No.
Yeah.
Martin. Okay.
T to the 4th.
How'd you get t to the 4?
Because the highest power of t, and that expression is t to the 4th.
And so you need to have the highest power so that everybody can divide into that. Right? So yeah, that's really what you do, is just look and you see what's the highest power. 4, boom, 4. Okay, and you can be robotic about it, but ideally you should understand why you're doing it as well. Okay? So that's cool. Now we know what our target is, 10t to the 4. All right, so we've got a t to the 4 here, and we've got a 3. Okay? What are we going to multiply the t to the 4 by to make it the same as the common denominator? Yeah, then I'll make it 10t to the 4. That wasn't too bad. Top and bottom. Now you don't really have to bracket 1, but whatever. What about 2t squared? What do I have to multiply 2t squared by in order to make the bottoms the same? I'm not ignoring you. I just know that you know. But that's cool. Someone knew, though. Anybody knew? Want to
What was the
answer?
question?
What do I have to multiply 2t squared by here to make the denominator the same?
What?
A 5 for sure. Okay, but look at the power.
2.
T squared. Okay? And then the same on the top. And I guess my LCD is kind of in the way. But that's okay. I can move it. And then minus. Okay? And then, 3, 5t. What's that got to be?
2t to the power of 3.
Excellent. 2t to the 3. Okay? And then 2t to the 3. People are like, oh, then I can cancel. No, no, no. That's why we did this. We did this so that you could actually do the opposite of simplifying, right? You're actually making the fraction proportionally bigger, right? So anyway, all right, so what are we left with? Well, remember, every one of these we've set up so we know the denominator is going to be 10 over t to the 4. I would check it out just to be sure. Don't just blindly do it. That's going to be 10 times t to the 4, 10 t to the 4, 10 t to the 4. Okay, but then you go 3 times 10. You can even do 30 here. And you can even do a 5t squared here. And you can even do the 6, oops, minus a 6t cubed there. Okay. Then you want to see if you can factor. In this case, can you factor the numerator? The bottom's already factored, but can you factor the numerator?
Yeah.
Almost.
Oh, no.
No, I looked at it too and I was like, oh, 5 and 6, they go into 30, but then you're like, well, yeah, but 6 doesn't go into 5 and 5 doesn't go into 6. No, I thought the same thing too. Okay? Good? Okay, and so then don't forget your closing statement, restate and restrict. Okay? And then go from there. So that was good. There's a binomial version, there's a monomial version, and then 7, it was F, wasn't it? Yes, okay. Okay, yeah, it's got some factoring, some common factoring, so that we may be sort of running into some difficulty there. All right. Okay, so here we go. All right. First step, factor. Okay, and that's what we do, right? We factor it. Oops. Come on back. There we go. Okay, so we factor. Can't factor the numerator, but the denominator. First thing we should do is common factor. Okay, there's a 2 that goes into all of these. T squared minus 7t plus, oops, 12. Yep, plus 12. Okay, and then over here, 2x minus 5. Does anybody see it? We can break up the middle term. What multiplies the 4 and adds the 4, but does anybody see it? Perfect square. Perfect square. Square root of that's 2x. Square root of that's 1. 1 times 2x is 2x. Double it, 4x. It's a perfect square trinomial. Okay. How many people saw that? Hands up. Okay. How many people didn't see that? Hands up. You're like, it's everybody else, sir. Yeah, I want to see if you're paying attention. Right? So I'll do that by decomposition, because you can always do it by decomposition. Okay, so you take your first term, you take your last term, and you say, okay, what multiplies to 4 and adds to 4? 2 and 2. Okay? So you take that middle term, that 4x, you break it up into 2 and 2, and because it's an x term, you go x and x. Okay? And for those of us who see it, beautiful. Oh, wait. I wrote x's down, didn't I? Did the book have x's?
It was T.
It was t, so I'm just an idiot. Okay. We got to figure out a rule, guys. What do you guys get if I make a mistake? And you guys catch me?
Bonus mark.
Bonus mark? 1 bonus mark?
On a test, yeah.
On a test?
Yeah.
Wow. What was the top? Do you remember what the top was? Is someone checking the? Oh, you don't know.
I think it was.
No, I'll check it. I'm just being lazy. 2x minus 5. A bonus mark, eh? Okay, good. We'll do that. I see I did it again, didn't I? What an idiot. All right. We hadn't decided the rule yet, so you don't get anything. Okay, that's all right then. Okay. All right, so this one we can also factor further. What multiplies to 12 and adds to 7, 3, and 4. But that one we have an a value that's equal to 1, so we can just go t plus 3 and t plus 4. We're going to have a huge common denominator, aren't we? Oh. I didn't make the question. The textbook did. Okay, so 2t minus 5 all over. Oh, I broke up that middle term, didn't I? Mr. Hanley.
Sorry, I think you made another mistake.
Where did I make it?
Wouldn't it be negative, like the 2 you just wrote right now? The
Oh, you're
two-
right. You got me. See, and we officially made it that the rule.
So do I get bonus mark?
You do. But you got to fight for them, right? Because I'm going to forget. So don't forget that mistake that you made. Write it down.
Are you serious?
Yeah, you got to fight for it. I'm not going to be like, remember and write it down. Too lazy for that. I make mistakes like this. Imagine, I'm not going to write that down. It's your mark, not mine. Right? My wife reminds me of stuff all the time, right? I'm an absent-minded person. Okay, 2t, common 2t, right? And then we go t plus, no, 2t plus 1, yeah. And then a common nothing, right? So we can always factor out a 1. And then go 2t plus 1. And we do have that binomial repeat, right? We know it's going to work out. We already know it's going to work. Because when the magic numbers work, it's going to work. Right? Okay, plus 2t minus 5. And then we go 2t minus 1. And then 2t minus 1. Now this is where it's a little bit weird to write it this way. And the reason why, I'll show you why when we write it this way, is when we do our lowest common denominator. I'll do it in a different way. Okay, what's my lowest common denominator? When we do the monomial part first, What's the monomial part? What's the monomial part? No one knows? 2. So we put a 2. We got to put 2 there. Okay, then we got a t minus 3 and a t minus 4. That's the binomial part's easy. And then we got a 2t minus 1. Is that correct?
Don't you have to square the 2t minus
Yeah.
1?
And that's what's weird about this when you write it like this and you don't write it as 2t minus 1 squared. Okay? We have to take the highest power of every binomial that we see. We see the 2t minus 1. So if you do this blindly, and you're just like, oh, we got a 2t minus 3, 2t minus 4, 2t minus 1. If I had a 2t minus 1 here, and a 2t minus 1 here, it would still be 2t minus 1, and not 2t minus 1 squared. But because I have the two of them locked together, the highest, remember, when I put that denominator down there, this is going to have to cancel out. One of the 2t minus 1s will cancel out if I do this, right? But if I don't have two of them aren't going to cancel out. Do you guys understand? It's going to be the highest power of that common denominator. Okay? Oh, I got to extend that. All right. And so, we want to make the denominators the same. Actually, I'm going to have to move to the left over a little bit. Because they made the common denominator very, very, very uncommon in some respects. Okay, so we have this 2t plus 1. Okay? And we have this 2t minus 3, t minus 4. So what do we need to have here so that we can multiply top and bottom by that value? We got to make the denominators the same. What am I missing? Olivia? 2t minus 1 squared, right? It's a little mean, but it is what it is. Okay? And so top and bottom by 2t minus 1 squared. Now for this one, of course, I'm going to write it as 2t minus 1 squared. Okay? And my top is 2t plus 5. What am I missing? Although the order looks different, it doesn't make a difference. What am I missing from my denominator? Little hint there. Here's my common denominator. Here's what I have. What do I need? Yeah?
2, t minus 3, and t minus 4.
Yeah, you basically say, I got that. What do I need? That, and that. Right? Okay? And then, of course, I got to have all that junk up here. And what you may be saying is, do I really have to multiply all these out? I mean, do I really have to do? Yes, you do have to do that. Because writing them all under one fraction is helpful. But I have to make this longer. Okay? But it is what it is. Okay? So for this one, I'm going to square this first. Oh, no, wait. Maybe what I should do is I should go 2t plus 1 times 2t minus 1. Because that's the difference of squares, right? And go 4t squared minus 1. Yeah. Because 2t plus 1 times 2t minus 1, see it's plus and minus? Okay, that turns into a binomial. Now I only have a binomial times a binomial. That's a little easier than if I was to square that, right? And then have 2t plus 1 times 2t or times 4t squared plus 4t plus 1, right? Or minus 4t plus 1. Or maybe not, whatever, it's up to you. Okay? I'm going to leave the 2 out here, okay? And I'm going to go to t minus 3 times t minus 4. Okay? You're like, do I really have to do? Yes, you really. In fact, this is actually technically probably should be part of our lesson, right? Because this is a difficult one to do, isn't it? And that's really what today's all about, the difficult ones. So 4t squared times 2t is 8t cubed. 4t squared times negative 1 is negative 4t squared. Negative 1 times 2t is negative 2t. And negative 1 times negative 1 is positive 1. Okay? This one I'm still gonna be simplifying inside the brackets, okay? So 2t times t squared, oh darn, I don't know if I'm out of room, I'll have to write smaller. 2t times t squared is gonna be 2t cubed. 2t times negative 7t is gonna be negative 14t squared. 2t times 12 is gonna be 24t. And then 5 times t squared is gonna be 5t squared. And then 5 times negative 7, negative 35t. I can't make this any skinnier. This is as skinny as it goes. Plus 60. Ah, we just fit it in. Okay? Oh. Close my bracket. Remember, it's a 2 by 3, so it should be 6 terms. 1, 2, 3, 4, 5, 6. Okay. All right. Okay. Oh, minus 1. Darn it. And you got to give me a little bit of time if you're going to catch me on these. Okay. A little bit of time, just a little bit. Okay. We can't do any collecting here until we expand out that 2. I'm going to write these guys smaller to begin with. That gives me more room. 2 times this. 2 times that. I guess I could have collected like terms in here, but I'm just going to expand it all out. 2 times that. 2 times that. 2 times that. 2 times that. In the end, you know you're not going to have to do this, because unless something adds or subtracts out in the constant, you don't know how to factor a cubic. So you know you're not going to have to factor anyway, but you still have to simplify that by adding the numerators together, or all, the 2 components of the numerators together. You still got to do it. Do I have to do that, sir? We just use the dishes. Do I have to wash them? I'm just going to make them dirty again, right? Because then you have the crusty food from the day before on top of the plate when you have the meal. You can't have that, right? You got to clean this up. You make a mess, you clean it up, right?
Sure.
Absolutely. Okay. I'm going to do a little bit of a canceling technique, so I'll do this in a different color, just to make sure we have everybody, because this is a monster. Okay. So we got 12. T cubed, then we got a negative 4, and then negative 28 is negative 32, and then a 10 is negative 22. Did I miss anybody? I don't think I missed anybody. I got a negative 2t, and a negative 70t, negative 72t, and then I got a 1, and a monster 120. Okay, so plus 121. And maybe this does factor, I don't know. It doesn't, I don't think it common factors. 3 out of there, 3 out of there, 3 out of, no, you can't get a 3 out of there. Anyway, I can't think of what a common factor would be if it was a monomial one. But it certainly isn't a 2 because of the 121. That's too bad, because at least we could have canceled a 2. We got a little bit of satisfaction out of all this, right? Oh, I did forget the 40. Or maybe it will cancel out. No, it's still not going to factor. But you got me. Make sure you write that down. That was a square. That was a square. So what do we have? We had a negative 2t. 48t is a 40. Is a 46t. And then a negative 70. 46. 24? Minus 24t. Is that right? I think that arithmetic's right. Yeah. But either way, still, because 3 doesn't go into 22, and doesn't go into 121, and 2 doesn't go into the last one. But it would have been nice if a 2 went into it, because then we could factor out the 2 and cancel out the 2. At least that would have been something, right? And then we were state restricted. Okay? It was a little ugly, wasn't it? Which brings us to our lesson. And the lesson part isn't really a long, you already know how to do this, okay? All right, so consider the following. When working with rational expressions, multiplying, dividing, adding, subtracting, we talked about those steps to success. What was the first step in everything that we did? Factor. What's the second step in everything that we did?
Things that won't work.
Right, restrictions. Restrictions. But yeah, that works too. Okay? All right, third step was we kind of did what we were supposed to do, right? We either multiplied, we flipped it, and we divided, right? Sorry, you guys flip it and then multiply. Sorry, when we were dividing. And then for adding and subtracting, we did the common denominator, but then we lowest common denominator, made them the same, added them up, right? We did the operation. So that's in essence what I did. I said, these are your steps to success. So I give you this example, and in this example, we have an adding and a division. But the first two steps are still the same. Factor. Now, there isn't much factoring going on in this example. Okay, no factor, no factor, no factor. Okay. And then step two, oops, come on. Step two, determine the restrictions. Same deal. Now, what's tricky is people go, okay, restrictions. X can't be 5, X can't be 0, X can't be negative 3, right? Excellent. Well done, Sean. You got to do the 4. When you're dividing, you got to do the whole numerator denominator fraction of the divisor. Okay? I said Sean, right? Okay. All right, so there they are. I mean, it was already up there, but that's okay. If you're focusing on this, then that's an honest thing that you did. Okay, step 3, you got to perform the operation. Now, BetMass is going to govern this because we're going to have multiple operations in there. When you have addition and subtraction, you can do them in whatever order they appear. When you have multiplication and division, you can do them from left to right in the order that they appear, right? But once you put it all together, you do have to have this. Now, we're not going to really have any brackets and exponents in this scenario, but we are going to have division, multiplication, addition, subtraction. Okay, so in this case, what do? Well, I kind of already did the first step, okay, just to save a bit of space. So I have a division, right? I do the division first, and I do say division first, okay? And I flip them, you see, I flipped it already, right? I made it a multiply. Then what do? Again, I kind of ignore this 3 over 2 plus. I just ignore the 3 over 2 plus. I don't like erase it. I just ignore it. And what do? I do the multiplication. Put these two guys together, so x times x plus 3, which is x squared. And then x minus 5 times x minus 4. What I don't do is expand it out. Because then I just have to factor again, right? So when you do the multiplication and division, do all that stuff, but don't crunch all the numbers out. You don't need to do that. Leave it, because we're going to need it to be factored again for when we do our other operation, in this case, which is addition. So now we add. So when we add, we build our lowest common denominator. And that's not difficult. Lowest common denominator is a 2, that's the monomial part, and then an x minus 5 and the x minus 4. So it is that one where you just multiply the denominator of one by the denominator of the other one, and that's my lowest common denominator in this case. Okay? Then what do? I make the denominators the same. So I look at the 3, and I look at the 2, and I'm like, okay, what do I need? Well, I got the 2, but I need that, and I need that, right? So then I put them there. And do the same thing to the top. And for this one, I'm like, well, what do I've got this. You know, this is what I have to begin with. All right, so what do I need from this? I just need the 2. So you put the 2 there, and you put the 2 there. Okay? Top and bottom, always. Whatever you do the numerator, do the denominator, and therefore it's still the same fraction. Okay? And then what do? We write them all over the same denominator, just like we did before, just like we did a second ago. Okay? And we kind of just, I don't know, write down what's in the numerator again. Okay? And then we expand it out. So we do x minus 5 times x minus 4. And then I always recommend to expand, your bracketed binomials first. Always. Okay? Okay, always. All right? And then you can distribute something. It's easy to distribute, so leave it for later, right? Okay? And then this one, of course, it is a simple distributive property, so I get 2x cubed plus 6x squared. Okay? Then I distribute the 3 through, and there I have it. Add them all up, collect the 3 and the 6. Put the 2x cubed first. Put the 3 and the 6 x squared together to give you 9x squared. Negative 27 is on its own. Negative 60 is on its own. Okay? And then, again, we always write in decreasing degree. Degree 3, degree 2, degree 1, degree 0. Okay? And then we look to see if we could factor. You guys don't know how to factor cubics, so you're just like, well, I don't know. Next year, maybe you're not going to say, I don't know. Maybe you're going to use your factor theorem in order to figure out how to do that. Okay? But this year, you're not going to worry about that. Okay? You'll be like, whew, I got that right. Hopefully I didn't make a mistake. No, I didn't make a mistake on this one. I Okay, and then of course R&R. And because I had some time to prepare this, I actually did R&R this time. I didn't just write R&R. See, I do it sometimes, don't I? I'm not lazy all the time, right?
Yeah.
Imagine how lazy I'd be if how fat I'd be if I was lazy all the time, right? Don't say that. Don't even imagine that, but it is what it is. Okay, so there you go. And don't forget about your restrictions, okay? Now, we haven't canceled any of the restrictions out, but by compiling them together, like the restrictions that we had here and here and here are the same restrictions that we would have had in the end in the individual fractions, but we didn't seem to cancel anything out, did we? Okay? All right. Let's try a few. In this case, with a few is going to be a few, literally. This one's a monster, isn't it? So what do we do? What do I have to do? Factor. I have to factor first? Are you sure? Yeah. I'm sure. Factor. Okay, so we're going to go ahead and I'm going to factor. I want to be a little bit quicker with this so we're not doing this for too long. So x minus 4x plus 1. Okay, and this is 2x, x minus 5. Yeah. Catch me if I make a mistake, okay? But I am trying to speed things up so you're not too bored and you do have some time to work. Some people may have a question as we move along, and that's okay, about what I do. If you do this or don't do this, it's still going to be fine, okay? But, oops, it's a 6x squared that I have in common there. Okay, so there we go. State restrictions. Okay, the restrictions I have for you here aren't too mean. So what are my restrictions? We got a 0, we got a 5, we got a 3, we got a -3, we got a 2. 0, 5. Where's the 1?
In the division, you gotta flip it over.
No, what did I miss? I'm joking, I intentionally missed that one. Yeah, the -1 there, okay? Now, don't do this one. You'll be like, what, it's got to be the second fraction. No. This is multiply. I'm dividing by the entire divisor, so I can't have a 0 here and I can't have a 0 here. Okay, only Chuck Norris can divide by 0. Okay? All right, so what we do then is the operation. Okay, and it would have been nice if I could actually have done the factoring and the division operation at the same time. Wouldn't it have been nice if I did that? Try not to do too much, but you could do that, couldn't you? What would I do if I was factoring at the same time as doing this operation? You just factor this guy and put it on the top, and factor that guy and put it on the bottom. Right? But that's okay. It's just a lot of work for me, that's all. You guys don't care though. Just watch the Mr. Henley show. I did design this so it was very satisfying though. Not like that big monster that we did, that was just not very well designed. That was unsatisfying. I'm even going to use another color because it's going to be so satisfying what we did. Okay. I mean, if you're weird and canceling out makes you happy. That's okay, I'm weird too. All right, now what do? The operation, remember, is we scooched them all together. You really should not cancel as a rule until you write it all as one fraction. You may say to yourself, they're all multiplied, so you could cancel top and bottom off of that through all those fractions, that's fine. But the mistake that people make is they sometimes cancel when that's like a negative or a positive. It's a plus or a minus. You cannot cancel from fraction to fraction. Now, in essence, when I have multiply and multiply, this is all one big term. You realize that, right? It's one term. Because they're all multiplied together. Anything multiplied together is part of the same term. Even if it's bracketed as a binomial and another binomial. Okay, so this is one term now. Okay, so as a result, you can cancel within a term. But sometimes it's good to have that mindset of, when it's one fraction, that's when I can cancel. Until it's one fraction, I can cancel. That one helped me out when things got crazy. When you're doing what you're gonna be doing next year. Okay, because I did all this stuff when I was in grade 12, not when I was in grade 11. So, we did more crazy stuff, but we also did some of the stuff that you did when you were in grade 11. Because we had 5 grades in high school. Like we had a grade 13. And you guys don't, so we had to scrunch it in, anyway, whatever. Okay, so there it is. Oops, I even forgot about it, because you do kind of forget about the 1 over x minus 2. Don't you? Okay, so now we do some canceling. It's going to be fun. It's going to be fun. You excited now? So satisfying. Okay, so what do I got? I got an x plus 3 and an x plus 3. X minus 3, x minus 3. Ooh, x minus 5 and x minus 5. X plus 1 and x plus 1. Look at that, was fun, wasn't it? I know you all have smiles on your faces, even though you have masks on, I can tell. Okay, does the x minus 4 cancel? No. I can't do everything, right? Even the monomials cancel. The 2 and the 4 cancel to give you a little 2. That's not exponent 2, that's a number 2. Okay? And then the 6 and the 2 cancel to give you a 3 down here. And nothing up here. And then the x squared and the x squared cancel here. And I'm left with an x down here. So what I really have, maybe I should rewrite this, is I'm left with just an x minus 4. And what am I left in the denominator? An x. And a 3. That's all right. Right? Wasn't that satisfying? You gotta admit that was pretty fun, right? Whatever. You're like, yeah, sir, that was fun. Stay off the drugs. Anyway. All right, so there I have here, and I still have some work to do, and I'm actually running out of room. Okay, I should give myself some more room, shouldn't I? Okay, so what do we do now? Yeah, I gotta do the LCD. I'll do the LCD over here. Okay, it's gonna be 3x times x minus 2. Not really difficult to do. Okay, so then I, of course, make the denominators the same. So I've got an x minus 4 all over a 3x. So what do I need to add to the 3x to make it look like this guy? The x minus 2, right? Right, and for this one, what do I got to add to this to give me this? Well, just the 3x. Some people would even say, dangerous, but you would cross multiply. Don't cross multiply. But you would cross multiply. Okay, don't ever cross multiply. Okay? Can you promise me you'll never cross multiply? Okay, good. That's good. It's like looking both ways before you cross the street. 99% of the time you're not going to get hit by a car, right? Because you hear it coming or whatever. But that one time, you get hit by a car. It probably hurts. Right? All right, so from there, what are we left with? Well, we've got the common denominator, 3x, x minus 2. And then we have the numerator. There's going to be a little bit of work here. X minus 4, x minus 2, well, I'm just going to multiply that out, 3x. I think that's okay for me to do, right? I'll expand this one out. Okay, x squared minus 6x plus 8 minus 3x all over 3x. You didn't think I was going to fit it, did you? You're like, how are we going to fit this? You know, x squared minus 9x plus 8. You're like, oh my God, is that factorable, sir? Is that factorable? It's factorable, isn't it? That's crazy. Isn't that crazy? Now, in this case, when you factor, it doesn't really help you, does it? Nothing cancels. Sorry, I couldn't make it that satisfying. I apologize for that. But this, in this format, is much more useful for you to graph next year. So you should finish off with it in factored form. Some teachers are like, don't worry about a just leave it like this. Once you've gotten this far, I'm just happy. You know? It's like scoring, running 99 yards to score a touchdown. and then having the good sportsmanship to pass the ball to the referee. If you want to spike the ball after doing that, spike the ball. If you want to drop the mic or drop the ball and just walk away, with a little bit of a saunter after you scored a 99-yard touchdown, I get it, okay? But it is nice to hand the referee the ball and do things right when you finish off. And if you don't understand the analogy, that's okay. Just try to factor it at the end if you can. Most cases you won't be able to. Good? Okay. Now, what I am going to do is I'll do this quickly for you. Okay? I'm going to have to stop the video because they already have this in a video anyway.